Hi. So a friend asked me about what happens to water in space. So when I was thinking about that, I thought about people in space. So I thought I'd discuss a little bit about human spaceflight and uh, the effects of space and the space environment on people, and then we'll get to the water. Something I've always found really interesting is that I'm going to use my phone for the picture. Um, that plane, the Kitty Hawk, was flown by the Wright brothers. It was the first plane in 1903, and just 66 years later, man was walking on the moon. It's an incredible feat for not a long time, and imagine where we'll be in 66 years' time, hopefully with a big colony on Mars. So, in 1959, the first satellite was launched into space by the Russians, and they also successfully launched the first man into space in 1961, Yuri Gagarin, on the 12th of April. So every year we have Yuri's night on the 12th of April. It's a few days from now. The Americans launched Alan Shepard successfully into space shortly afterwards, and then there was significant progress through the 60s. And as we all know, with Apollo 11 in 1969, Neil Armstrong was the first man to set foot on the moon, along with him Buzz Aldrin, who I can excitedly say I got to meet last year, so my work here is done. There were 6 manned missions to the moon in the early 70s, and 12 people walked on the moon. So space is an interesting environment. It's very challenging for the human body. One, it's a vacuum. There's no air, very little pressure, and extremes in temperature. Super hot when you're in the sun, like a couple of 100 degrees centigrade, and equally as cold when you're outside of the sun. Spacecraft have a lot of challenges. I spoke to you about plasma and charged ions coming from the sun. So these can charge materials in and on spacecraft, like our satellites, which we rely on. And these charges can discharge. It's called a discharge arc, and it basically shoots off a little electric current, and this can damage solar panels and electronics. Not many people realize how much we rely on our satellites that are in space for our communications, weather updates, cell phones, ATM machines when you draw cash. Life as we know it today is completely reliant on satellite interactions. So keeping them healthy is really important, and there are many challenges. We have outgassing. This is where gases that are trapped or dissolved in materials like plastics can suddenly get rid of their gases once they're in the space environment, and this can damage equipment. Cold welding in space. So if you've got 2 pieces of metal and you touch them together, on Earth, even though they feel like they're touching, there's actually a layer of air between them. In space there isn't. So when you try have moving machinery that's made up of the same metal and it touches, it will just instantly weld and your materials are stuck together. The human body, so as you can imagine, in microgravity on the space station, we call it microgravity because it's not exactly zero gravity. I won't get into why that is, that's a talk on its own. But when you arrive in that environment, you have a number of challenges. On Earth, gravity interacts with the liquids in our ears, and that's how we tell if we're upright or not. But in space, there's no way of doing that because the fluids are not being affected by gravity. So that can take time to adjust. Something I also found very interesting is the heart. On Earth, because of gravity, blood is sort of pushed to our extremities, to our hands and feet. But when you first get to space, it pulls around the heart, and when your body detects too much blood around the heart, it reabsorbs that blood and reduces the amount of blood quite significantly in your body. So you have a lot less blood in your system when you're in space. And interestingly, when you're back on Earth, your body knows to create more blood again. Water. Okay, water in space. So I'm sure you've all seen the videos of astronauts playing with bubbles of water in the space station. But that's an environment that's protected. It has pressure and it has air inside. If you had to put water outside the space station, just in the vacuum of space, interestingly, two things happen. It evaporates, boils and evaporates, and freezes. Both happen. So a drop of water has a very strong surface tension. You know, you see it stay as a drop. All those water molecules are kept inside. That gives it a lot of resistance to temperature change. So freezing all of those molecules instantly is quite difficult. And another interesting thing about water is that the lower the temperature and the lower the pressure around water, the lower the temperature it needs to boil. So when you're on top of a mountain, you can boil water at a lower temperature than when you're at sea level. So in space, there's no pressure in the vacuum of space. So it almost instantly boils. But as it boils, the molecules turn to water vapor, and then because of the cold, they freeze. So water in space actually boils and freezes. I hope that made sense. So yeah, a little bit about spaceflight and the space environment, and see you tomorrow.